So this will be the last part of the section P1 video. You really need to do section P1 really intensely because P2 kind of uses the rules of P1 but uses them with negative exponents, so it's quite a bit harder. So you have to have this section understood perfectly. The next problems are just slightly more complicated problems that apply the rules that we've been learning, and maybe they apply some other algebra that we haven't looked at yet, but you're supposed to remember. And that's the case with problem 42. Problem 42, it's going to use rule 2. I'm dividing when the bases are the same, because in this problem 42, I'm dividing y to the 11th and y to the 8th power. And when I divide those, I'm going to wind up subtracting the exponents. When I'm dealing with a fraction, when I do that subtracting, I usually leave that subtraction in the numerator of my fraction. So the part of problem 42 that uses the rule that we developed in this section, I'm dividing and the bases are the same. As long as in the numerator and the denominator there isn't any adding or subtracting, just like for that rule 3, we can just use the rule how it's written and maybe treat the numbers differently. And in problem 42, I need to treat the coefficients of 3 in the numerator and 12 in the denominator differently. I'm just treating this as the fraction 3 over 12, and I'm going to reduce by 3. I'm going to go 3 divided by 3 is 1. 12 divided by 3 is 4. So I'm going to get a 1 in the numerator and a 4 in the denominator. This calculator, if I'm cruddy at reducing fractions, type my fraction button, do 3 in the numerator, arrow down, do 12 in the denominator, hit the equal sign, it tells me that it's 1/4. So simplifying this, the numerator would be 1 times y cubed. I don't need to write a coefficient of 1, it's assumed. And in the denominator, 4. This would be a beautiful answer. It turns out that if you were working ahead, you might have written your answer differently. My numerator that came out really 1 times y cubed over 4. I don't want to get too lengthy here because the videos are going to get kind of long. But if you wrote the problem, your answer, with the fraction 1/4 to the left of y cubed, this actually equals, and is a correct answer. This has to do with this y cubed is really y cubed over 1. I could think this is going to get, I don't even want to explain it. But if you want me to explain why this and this are the same and both correct answers, I can. Take me 2 or 3 or 4 minutes, and then it might start confusing more students than it doesn't confuse. This is how I'd probably write the answer in an algebra class. Turns out that this version of the answer has a place in a calculus class. When you do something called derivative calculus, this style of answer makes it easier to do something called a derivative. Not that that's an important deal now. In problem 44, I kind of need to think of this as 3 separate problems. I'm going to reduce the fraction 6 over 24. I'm going to reduce the fraction a over a, and I'm going to reduce the fraction b cubed over b. Because there isn't any adding or subtracting between the numbers and the letters, I don't really have any risk of reducing something that I can't. So first I'm going to go 6 divided by 6 and get a 1, 24 divided by 6 and get a 4. I know for certain I'm going to have a 4 in the denominator of my answer from the 1/4. The coefficient of 1 in the numerator, usually I can suppress a coefficient if there's more, so I'm not going to write that yet. The a's are identical, they're going to cancel, so I'm not going to worry about writing an a. And for the b's, I'm going to subtract the exponent. The b in the numerator has an exponent of 3, the b in the denominator has an exponent of 1. I'm going to subtract and leave the letter in the numerator. This is going to give me a b to the 2nd power. This would be a great answer for an algebra class. If I had written the 1 as the coefficient and written 1b squared over 4, that's equally a good number, a good answer, but an odd way to write it. Usually I wouldn't write a coefficient of 1. But If I wanted to write that b so that it wasn't in the numerator and it was written separately and the 1/4 looks more like a coefficient, that would be, then the 1 would be necessary. All three of these are correct answers. This is probably what I would instinctively write in an algebra class. This is what I'd probably instinctively write in a calculus class. We don't need to worry about calculus right yet. The next few problems, 46 and 48, are just actually 46, 45 through 50 are straight multiplications. This is kind of easy. Since there isn't any adding or subtracting inside the parentheses, I'm just going to multiply the like pieces by the like pieces. In problem 46, I'm going to multiply the 6 and the 3. I'm going to multiply the x to the 4th and the x to the 5th. Those are, have the same bases. And I'm going to multiply the y to the 5th and the y to the 4th. Generally, I would do this all in my head. I probably shouldn't have written the time sign between the x's, that's implied. But if I'm showing the work, I need the time sign between the numbers, otherwise it looked like the number 63. Multiplication's commutative, so I can just shuffle the orders of the multiplication around. And the parentheses here, we're just kind of separating the factors being multiplied. When you have multiplication, the pieces inside the parentheses are properly called factors. I'm just going to multiply the like pieces, like terms. 6 times 3 is 18. I'm going to use rule 1 for the x's. I'm multiplying terms that have the same base, so I add the exponents. And I'm going to use the rule 1 for the y's, add the exponents. Usually when we have more than one letter in an answer, or more than one variable and letters are interchangeable, they mean the same thing for us, I guess. I usually write the letters alphabetically, so the x alphabetically before the y. In problem 48, the x in the first parentheses has an implied exponent of 1. The x and the y both in the second parentheses have implied exponents of 1. If I was trying to show work in problem 48, I'd multiply the 9 and the 8. I'd multiply the x to the first in the first parentheses and the x to the first in the second, and the y to the third in the first and the y to the first in the second. Probably wouldn't write the exponents of 1, I just think that they're there. 9 times 8 is 72. Add the exponents using rule 1 on the x's and get x squared. Add the exponents on the y's using rule 1 and get y to the 4th. Problem 50, that second parentheses, if it bugs me, has an implied coefficient of 1, and it might help me as I simplify this. In the first parentheses, both the x and the y have an implied exponent of 1. So this would be a way to imagine problem 50 written so maybe it looks more like 46 and 48. To simplify this, I'd just drop my parentheses. I'd multiply the 15 and the 1. I'd multiply the x to the first and the x to the second. I'd multiply the y to the first and the y to the first. There isn't any adding or subtracting. Multiplication's commutative, so I can just drop the parentheses, multiply the like terms, shuffle the orders around to get this written nicely. For an answer, 15 times 1 is 15. Use the rule that I'm multiplying with like bases and add the exponents on the x's and get x cubed. And add the exponents on the y's and get y squared. So my best answer for 50 would be 15x cubed and y squared. You should be able to finish all the odd problems on this sheet. We're getting closer. I just have kind of 2 sheets left, but they've got some chunky problems on it. Problems 52, 53 are more or less just the same problems that we've been doing. I'm going to rewrite the problems without the parentheses. I wouldn't probably group these in my head the same way. Problem 52, this exponent is supposed to be a 2. It looks like a z. I don't know why. Oh, you can't see 52. Good. Problem 52, I just changed the exponent that looked like a z to a 2. In problem 52, I would say this is x squared times x to the first. I don't need the coefficients here because they're 1s. Y squared times y to the first, and z to the first times z cubed. If I was doing 52, I would just write an answer down because I can do this multiplication in my head. But if you want to, drop the parentheses, multiplication's commutative, change the order of the multiplication, insert the exponents that are assumed but not shown if you need. And for an answer, I would have x cubed, y cubed, and z to the fourth. This isn't the only correct answer because multiplication is commutative. I could have said this is y cubed, z to the fourth, x cubed, but it's customary to, if there's more than one variable, to write the variables alphabetically. In problem 54, the first parentheses has a 1 that I'd multiply by the 7 in the second parentheses. The first parentheses has an x to the first that I'm going to multiply by the x to the first in the second parentheses. Then the y cubed in the first parentheses times the y cubed in the second parentheses. The z squared in the first parentheses times the z to the first in the second parentheses. Usually it's nice practice if you're writing something that's a step along the way to the answer to write an equal sign, meaning it equals what's above it. For an answer, I usually box my answers. 1 times 7 is 7. Add the exponents on the x's. Add the exponents on the y's. Add the exponents on the z's. I'm getting 7 x squared y to the 6 and z cubed. 55 and 56, as well as 57 and 58, have exponents outside of parentheses. I need to deal with that first. So in problem 56, I need to first deal with the negative 4 x squared y squared all cubed. And I'm going to simplify that, leave it in a parentheses, and then I'm going to tack on the 2xy part. I'll deal with that second. To deal with this parentheses, I'm going to leave the negative 4 in a parentheses. It doesn't have an exponent. I'm going to use rule 3. I'm going to multiply its exponent of 1 times that 3 and get a 3. When I'm using the rule 3, any number or letter that doesn't have an exponent, I just attach the exponent rather than showing the times the 1. The x has an exponent of 2. I'm going to multiply 2 times 3 and get 6. The y has an exponent of 2. I'm going to multiply the 2 times 3 and get 6. The negative 4 cubed part, using the negative by the fraction here, negative 4 cubed is negative 64. So the first parentheses, it simplifies to negative 64 x to the 6th y to the 6th. I'm writing my first equal sign because this is what actually equals the line above it. This is just some work I did on the side to improve the parentheses. It doesn't equal the whole line above it because I wasn't writing the 2xy part down. Now I'm going to simplify. I'm going to multiply the negative 64 and the positive 2. I'm going to multiply the x to the 6th in the left parentheses times the x to the first in the right parentheses, the y to the 6th in the left parentheses times the y to the first in the right parentheses. Again, if there was addition or subtraction between the numbers and the letters, I can't do this. It's way more complicated. But here I've got this flexibility. So now negative 64 times 2 is negative 128. Use the rule 1 to add the exponents on the x's. Use the rule 1 to add the exponents on the y's. And I get negative 128, x to the 7th, y to the 7th for my answers. On problems 57 and 58, I need to deal with both parentheses. Both parentheses have an exponent outside, and I need to deal with it before I make the two parentheses combined. So first parentheses, I'm going to multiply the exponent of 2 on the x by the 3. The y doesn't have an exponent, so I'm going to attach it. The first parentheses is going to simplify to x to the 6th times y cubed. Second parentheses, since there isn't any addition or subtraction inside the parentheses, any number or letter that doesn't have a parentheses, I can attach the exponent. That's the same as multiplying 1 times the exponent. So I'd get 2 to the 4th, x to the 4th. Any number or letter that has an exponent, I'm going to multiply and get y to the 8th. This is using rule 3. 2 to the 4th I can do without my calculator. It's just 16. And then I already have the x to the 4th and y to the 8th. If I need to, the first parentheses has a coefficient of 1. That's assumed. So to simplify this, it's 1 times 16, x to the 6 times x to the 4th, y cubed times y to the 8th. 1 times 16 is 16. Add the exponents on the x's using rule 1, add the exponents on the y's using rule 1, and I get 16x to the 10th, y to the 11th. Just a few more problems, 3 more problems, and we'll call it quits. This rule 3 applies to fractions, and so I'm going to use rule 3 as long as if there's an exponent outside of parentheses, as long as the problem doesn't have addition or subtraction inside the parentheses, then the shortcut to simplify the parentheses is to multiply the exponent by any number or letter that has an exponent, and instead of writing an exponent of 1 and then multiplying the exponent, attach the exponent to any number or letter that doesn't have an exponent. In problem 60, the proper way to think of this is y to the 4th over 3 to the 1st, and it's proper to go y to the 4 times 3 over 3 to the 1 times 3 and make this y to the 12th over 3 cubed. That's good, but not the best. If I was doing this problem in a parentheses that doesn't have any adding or subtracting, to clear the exponent outside the parentheses, I'd multiply the exponent by any number or letter that has an exponent, attach the exponent to any number or letter that has an implied exponent of 1. And this is going to give me y to the 12th over 3 cubed. 3 cubed is okay to leave in your answer, but I'd probably write it as 27. And my calculator, I can do this all day. Do 3 exponent key 3, and 3 cubed is 27. So for an answer for problem 60, y to the 12th over 27. 62, I'll shortcut it. The exponent of 3, I'm going to multiply by the exponent of 2 on the x and get x to the 6th. And I'm going to attach the exponent of 3 to the y and the 3 in the denominator. I have a parentheses with an exponent outside. If there is an addition or subtraction inside the parentheses, to clear the parentheses, I'm going to multiply the exponent by any number or letter that shows an exponent. I'm going to attach the exponent to any number or letter that doesn't show an exponent, rather than showing this business of multiplying the exponent of 1 by the exponent outside the parentheses. For an answer, 3 cubed is 27. I don't need to do that again on my calculator. There's probably alternate ways to write this, but I like this one best. Last problem. Again, I'm just using a combination of rule 1 and rule 3. Rule 3 kind of shortcutted. As long as there isn't any adding or subtracting inside of parentheses, I can clear the parentheses by multiplying the exponent outside the parentheses by any exponent I see inside the parentheses, and attaching that exponent to any number or letter that doesn't have a shown exponent inside the parentheses, kind of shortcutting. So multiply the exponent of 2 and 4. For the 3, I'm going to, instead of multiplying 1 times 4, I'm just going to attach the 4. For the y in the denominator, instead of multiplying 1 times 4, I'm just going to attach the 4. And for the z, I'll multiply. And real quickly, since the number wasn't negative, it didn't need to be put, the 3 didn't need to be put in a parentheses. If the 3 was a negative 3, I have to put it in a parentheses on this step. The 3 to the 4th is 81. So for my final answer, I'm going to get x to the 8th over 81, y to the 4th, and z to the 12th. So hopefully you followed along and were able to do all the odd-numbered problems in this section, and hopefully you checked all your answers to make sure they're right. So you really need to take some time and make sure you really understand these 3 rules from section P1 before you march on to section P2, because section P2 uses these rules again, but it makes the exponents negative, which just makes everything harder. All right, so I'm going to stop the